Hello, welcome to ANS Solver. This is the second question of the paper. The time in minutes that John takes to travel to work has a normal distribution. So last year he took a mean of 26.5 and a standard deviation of 4.8. Okay, so this year John uses a different route, okay, and he finds that the mean time of his first 150 journeys is 27.5 minutes. So I can say this is my test value, this is the number of journeys I took, this is my mean, and this is my population standard deviation. So I got everything in one go, and this is my significance level which they have given me. Okay, so now I need to test whether the mean time for his work has increased. So I can state the null hypothesis, which is the first claim, that my mean is equal to 26.5. My alternative hypothesis will be the rival claim for what I'm testing for. He's testing for that the work or the journey time has increased. So the mean has increased. So now what I basically need to do is I have my normal distribution curve something like this. Okay. Now I know there's a 1% significance level and this sign is more than. So I know the 1% significance level is more than the mean. Okay, somewhere here with 0.01 here because it's 1%, so it's 1 over 100. So now what we basically need to do is we need to find a z value for this. I know if this is 0.01, this is 0.99. So I can go to the z values here. I can spot the 0.99 probability here, which has a z value of 2.326. So I can take that value and write this as 2.326. Got it? So now what I need to do is I need to find my z statistic value, which basically has a formula of the test value minus the mean over the standard deviation over root n. So my z star value is basically the mean or the test value, which I know is 27.5 minus the mean, which is 26.5 over the standard deviation, which I know is 4.8 over root of the number of journeys I took, which is 150. Correct? So now I can simply calculate my z star. So I can write this at 27.5 minus 26.5 on the calci with 4.8 over root of 150. So when I solve this, I get my answer as 2.5515. Now I need to compare the z value, the mod of z value, and the real z value, the significance level z value. So I have 2.5515 here, okay, and I have 2.326 here. 2.5515 is bigger. That means 2.5515, I know. Think about it graphically. In the z values, 2.326 lies somewhere here. So 2.55 lies somewhere here, which basically lies in the critical region of 0.01. That means I reject my null hypothesis and I accept that the mean journey time has increased. Okay, so I reject the null hypothesis, and I can say that there's evidence of mean journey time increasing. Okay, this is what I can state. Now, state with the reason whether it was necessary to use a central limit theorem in your answer. So central limit theorem we use when the distribution is not specified whether it's normal or no. And that time we see if the n is more than 30 and then we approximate it to normal. But here if you see, they have stated that this has a normal distribution. So why do we need to assume that, why do we need to use central limit theorem, okay, and assume that it's normal distribution? So I can just say no, as it is stated that the distribution is normal. Okay? Yeah.